at LG Institute of Engineering and Technology. Today we will discuss few more topics of indeterminate forms. So let's begin with the first topic, that is indeterminate forms of the type 0 into infinite. To solve the problem of the type limit x tends to a f of x into g of x when limit x tends to a fx equals to 0 and limit x tends to a gx tends to infinite. Okay, so whenever fx limit x tends to a f of x is equal to 0 and limit x tends to a f g of x tends to infinite, so you will get the form 0 into infinite. Now we will write limit x tends to a f of x into g of x is equal to limit x tends to a fx upon this gx we will take in denominator, that is 1 upon gx, or gx we will keep as it is and this fx we will take in denominator, that is gx upon 1 upon fx. Okay, these new forms are the type 0 by 0 or infinite by infinite, and whenever we have the type 0 by 0 or infinite by infinite, we can apply L'Hopital's rule. Okay, and you have to solve this example using L'Hopital's rule after converting into 0 by 0 or infinite by infinite form. Okay, now let's begin with the example. Evaluate limit x tends to 0 x into log x. So let's begin with the solution. Consider this limit as n. Okay, now if you will substitute x is equal to 0 here, so you will get 0 into here log 0, that is infinite, so you will get the form 0 into infinite. Okay, so what we will do, we will take one term in the denominator. Now you have to remember one thing, that we will never take this log term in denominator. Okay, log will always remain in numerator, the other algebraic term or trigonometric term will goes to denominator. Okay, so this x will goes to denominator, that is 1 upon x. Now if you will substitute x is equal to 0, so you will get the form infinite by infinite. Okay, so now we can apply L'Hopital's rule, means we have to take derivative of numerator and denominator separately. So derivative of log x is 1 upon x and derivative of 1 upon x is minus 1 upon x square. Simplify this, so you will get limit x tends to 0 minus x. Now substitute x is equal to 0, so you will get answer 0. Okay, so the answer of limit is 0. Now next example, evaluate limit x tends to 0 log 1 plus x upon 1 minus x into cot x. So we will consider this limit as L. Okay, now if you will substitute x is equal to 0 here, so this term, these two are 0, so you will get log 1, that is 0, and cot 0 infinite, so you will get the form 0 into infinite. Okay, now what we will do, we will bring this cot function in the denominator. Why? Because log we will keep always in numerator. So we know 1 upon cot x, that is 10x, so here we have 10x. Now if you will substitute x is equal to 0, you will get log 1, that is 0, and 10 0 0, so 0 by 0 form. So we will apply L'Hopital's rule. Okay, so we have to take derivative of numerator and denominator separately. So the first derivative of log 1 plus x upon 1 minus x will be 1 upon 1 plus x upon 1 minus x, so it will become 1 minus x upon 1 plus x, and now we have to apply u upon v rule to solve this. Okay, so denominator as it is means 1 minus x as it is, derivative of numerator 1 minus this numerator as it is, that is 1 plus x as it is, derivative of denominator, that is minus 1, so minus minus will become here plus, and denominator squared, so here we have 1 minus x whole square. Okay, so this x will get cancelled. Okay, and simplify this, so 1 minus x will also get cancelled, so you will get 2 we will take outside, limit x tends to 0, this 1 plus x into 1 minus x will give 1 minus x square. Bring this x square x in the numerator, so you will get cos square x. Okay, now if you will substitute x is equal to 0, so you will get cos 0 as 1, this term is 0, so the final answer of limit is L is equal to 2. Okay, now we will discuss indeterminate form of the type 1 raised to infinite, infinite raised to 0 and 0 raised to 0. Okay, so to evaluate the limit of the type limit extends to a f of x raised to g of x, which takes any of the form 1 raised to infinite, infinite raised to 0 or 0 raised to 0 for the function fx greater than 0. So we will proceed as follows. Firstly, what we will do, we will consider this limit as L and this fx is greater than 0. Now we will apply log on both the sides. So you will get log L is equals to log limit extends to a f of x raised to g of x. So we will apply log formula. So you will get limit extends to a, this gx will come here and we have log fx. Okay, now this limit will take the form infinite into 0. Now we know the method to solve this form. Okay, so we will bring this gx in the denominator and we will solve it. So let's suppose we get this answer as k. Okay, so log L will be equals to k. And now we will take anti-log on both the sides. So you will get the final answer of limit L, that is e raised to k. Okay, so we will follow this method to solve the sum of the type 1 raised to infinite, infinite raised to 0 and 0 raised to 0. So let's begin with the example. Prove that limit extends to 0 a raised to x plus b raised to x plus c raised to x upon 3 whole raised to 1 upon 3x is equal to abc raised to 1 upon 9. Okay, so firstly we will assume this limit as L. Okay, and if you will substitute x is equal to 0, so you will get a raised to 0, that is 1 plus b raised to 0 1 c raised to 0 1 upon 3 and whole raised to here 1 upon 0, so it will become infinite. This 3 upon 3 is 1, so you will get the form 1 raised to infinite. Okay, so what we will do, we'll take log on both the sides, so you will get log L is equal to limit x tends to 0 log of this term. Okay, now we will apply the log formula. So bring this 1 upon 3x here. So you will get log L is equal to limit x tends to 0 1 upon 3x into log a raised to x plus b raised to x plus c raised to x upon 3. Now this will give the form infinite into 0. Now to solve this, what we will do, we will just rearrange the term. So you will get limit x tends to 0 log e raised to x plus b raised to x plus c raised to x upon 3 and whole divided by 3x. Now if you will substitute x is equal to 0 here, so you will get the form 0 by 0. Now when we have 0 by 0 form, we will apply L'Hopital's rule. Okay, so you will get log L is equal to limit x tends to 0. Firstly, take derivative of this term. So log x, we know the derivative of log x is 1 upon x. So you will get here 3 upon a raised to x plus b raised to x plus c raised to x. And now we have to take derivative of this term. So you will get a raised to x into log a plus b raised to x into log b plus c raised to x into log c upon 3. And derivative of 3x is 3. Okay, now substitute x is equal to 0. So you will get log L is equal to here 3, this 3 will get cancelled and here you will get 1 upon a raised to 0 plus b raised to 0 plus c raised to 0 into here a raised to 0 log a plus b raised to 0 log b plus c raised to 0 log c upon 3. Okay, and on simplification you will get here 1 upon 3 into log a plus log b plus log c upon c. Okay, now apply this log formula, so you will get log ABC and this 3 into 3 will give you 9. So it will become log L is equal to log ABC raised to 1 upon 9. Okay, so on taking anti-log on both the side, you will get L is equal to ABC raised to 1 upon 9. Okay, so this is what we want to prove. Now let's begin with the another example. Limit x tends to 0 1 upon x raised to 10x. So consider this limit as L. And if you will substitute x is equal to 0, so 1 upon 0, that is infinite, and 10 0 is 0, so you will get the form infinite raised to 0. So we will apply log on both the sides. So you will get log L is equal to limit x tends to 0 log 1 upon x raised to 10x. Now apply log formula, so bring this 10x here. So So you will get log L is equals to limit x tends to 0 tan x into log 1 upon x. Now we know this log 1 upon x we can write as log x raised to minus 1. Okay, and this can be written as minus log x. So we will write this log 1 upon x as minus log x and bring this 10 in the denominator. So you will get cot x. Now substitute the limit. So you will get the form infinite by infinite. Now if we have infinite by infinite form, so we will apply L'Hopital's rule. So you will get log L is equals to limit x tends to 0 minus 1 upon x minus cos x square x. Minus we get cancelled and what will remain is minus 1 upon x. This cos square x we will write as 1 upon sin square x. Okay, so bring this sin square x in the numerator and x here denominator. Now we will multiply and divide by x. So you will get x square and here x. Now we know this limit x tends to 0 sin x upon x is equal to 1. So we will apply that. So you will get this from here you will get 1 and if you will apply limit x tends to 0 here so you will get 0. So the final answer of log L is equal to 0 and taking anti-log on both the sides so you will get L is equals to e raised to 0 that is 1. Right? Now let's begin with the another example. Prove that limit x tends to 1 into 1 minus x square raised to 1 upon log 1 minus x is equal to e. So we will consider this limit as L. And if you will substitute x is equal to 1 here, so 1 minus 1 that is 0 and here 1 minus 1 so log 0. Okay, so that is infinite. So 1 upon infinite it will become 0. So here we have the form 0 raised to 0. Okay, so again we will take log on both the sides. So you will get log L is equal to limit x tends to 1 log 1 minus x square whole raised to 1 upon log 1 minus x. Now again apply the log formula. So this term will come here that is 1 upon log 1 minus x and log 1 minus x square. So now this limit will give the form 0 into infinite. Okay, so we will just rearrange the term. So you will get limit x tends to 1 log 1 minus x square upon log 1 minus x. Now this will give you the form infinite by infinite. Okay, so what we will do, we will apply L'Hopital's rule. So on applying L'Hopital's rule, we will get log L is equal to limit x tends to 1. 1 upon 1 minus x square into applying chain rule, you will get minus 2x and upon minus 1 upon 1 minus x. Simplify this, so you will get log L is equal to limit x tends to 1. This minus will get cancelled, so 2x. Bring this 1 minus x in the numerator, okay, and this 1 minus x square denominator. Now we will expand this, so we will write this 1 minus x square as 1 minus x, 1 plus x. This 1 minus x will get cancelled and what will remain is log L is equal to limit x tends to 1, 2x upon 1 plus x. Okay. Now just substitute the limit. Okay, so in place of x write down 1. So you will get log L is equal to 2 upon 2. It will get cancelled. So we will have log L is equal to 1 and taking anti-log on both the sides. So you will get L is equal to e raised to 1. This is equal to e. Okay, so this is what we want to prove. Right. So I hope you have understood. Thank you for watching.